Hello, my name is Mikey. I am head of manufacturing in the year 2024, and I figured it would be in the robotic team's best interest to create a comprehensive video guide on making things on the CNC within Fusion 360. So this tutorial will be assuming you have a basic knowledge of Fusion 360. You can speak to most of the people on the team if you need to learn more, but yes. Hopefully in the future we will have other ways of using the CNC besides using Fusion 360, but for now, this is the best option. So, to begin with, we are going to start with our basic model. This is a model that I made for my mom for Christmas. I never actually gave to her, but at this point Christmas has long passed, although some of the videos that you'll see later, it is currently Christmas. This will be... You can see this is the stand that this part slides into. How it would really look like is this. This front part would be metal. This back part would be wood. For the most part, we use aluminum in the shop for the CNC, and any wood will do. This will also be wood over here as well, and it'll slide in there. I'd typically make two of these and make them mirrored, but for this tutorial, I'm just going to be doing one. So the very first thing that you have to do is from this design part up here, go down to manufacture. This will go into it opens up like a new menu that you have to use to do all the manufacturing functions that you need to do. Very first thing is, if you ever see me open this up, you press S. So I'll just type in manufacturing and you'll see create manufacturing model. So if we do that, it'll basically, I can right click on it and say edit manufacturing model. Manufacturing model is basically just think of it like a separate model from the design one that you'd see up here, not design, manufacturing model. It is just a specific model, like a change in the model that you just use for manufacturing, although keeping the orientation for design might be easier to keep it in normal orientation. Manufacturer, you can change the orientation. So I'll just show you that it looks like. Of course, we cannot have this metal plate under the wood and manufacture that. It's going to be really annoying if we were to do that. So just gonna grab the aluminum. Actually, it's on the same axis. Yeah. Gonna grab the wood plaque, move copy. I'm just gonna shift it over here and make it level. I think it's 0.25 off or 1.25. Yeah. All right, we're good. So from here, now we have a finish edit. Now we have a manufacturing model that we can work with that is a lot easier to work with than the design model. Now, what I'm going to be doing next is creating a setup. A setup is basically just a set of information that we use to do functions on the CNC. This sounds very strange. Just know that it's like precautionary things that we do beforehand, all right? Just click on setup. And it'll bring up this menu. Basically, this initial big square here is where it is assuming your stock to be. So what I'm just going to be doing first is this wood piece here. So I can click on model, click on that. And this block over here is where we'll be changing all the parameters for the cuts. You may refer to them as cuts or mills. Same thing with the actual bits on the CNC, where they are either I can call them a mill or a bit. They're the same thing, really. Most of these things you can ignore, but this work coordinate system, it basically involves where we set our 0 point to be. So I just know the general way that our CNC is oriented, and we always want to have the x-axis and the y-axis on the same plane, going this way. Always in one of the corners. You can kind of change the rotation of it, but it's not worth it in my opinion. Let's just keep it as it is. Keep it simple, stupid. Keep it up here. And now if we can look at how this stock, where it's again, the stock is the material that we're cutting out of. Fusion 360 is assuming that our stock is going to have this little extra bit that we want to cut off. But we're gonna have to go up here. I want to say no, we do not have any extra. So the stock top offset we have set to 0.0. I can set this to 25 and it will go up accordingly. But the side offset is good at 0.4. All this really means is that once our CNC is zeroed, which you'll see later, it's just going to move 0.4 inches this way and 0.4 inches down before it actually like assumes where it's cutting. It's not that big a deal. Yeah, this is all you have to do for setup. Now that we have our setup completed, we're going to be doing, for this tutorial, we're really going to be doing 3 big, I want to say effects, functions in cutting them, in milling the stock or whatever it is. Very first one is bore, and bore is almost always first, because if you imagine a piece of, let's just say a piece of wood on the CNC, we need some way to secure it down to the board so that when the bit is spinning, it does not flick off pieces, like the whole thing, because there's nothing keeping it to the board. So what you typically see done is screws going like up and down this way. And that's fine, but what happens if you have to go around a part that cannot be attached to any stock? Well, then you're going to have screws within this piece itself. So we always start with what is known as these holes. So as soon as you press 4, you'll see this menu open up over here. I have a document called Speeds, CNC Speeds and Feeds. So this is the main document I refer to whenever I'm cutting anything that contains all of my speeds and feeds. I'll likely attach this in the description down below, but I know for plywood it's 180 inches per minute. The feed is basically how the distance that the bit is moving, versus the speed is how fast this bit itself is spinning. And if you don't know, RPM stands for rotations per minute. We're not going to exactly, I just want to have this up. For right now, I'm going to go to here, and I'm going to do the next very important part, is selecting our tool. So if you click on this tool, nothing will pop up because it doesn't know what's there. I have stuff in my local library, but let's just say that you are completely new to this. I have also attached in the description below a library full of tools. So I can download this. It'll be in downloads. This is the library. And if I go to here, now that it's just basically a text file that contains some information about all of them, so you don't have to, all the different bits, so that you do not have to manually import them yourselves. So now we can just right click on this, import tools, library tools. Great. This is everything. This is all we're going to be using. In fact, we're really only going to be using this bit here, 4mm 50 OAL. Why can I not? There. Select that, 4mm 2 flute, 51mm. Great. Making sure nothing. Yeah. Now that we have our bit selected, it'll pop down here, and we can enter in the speeds and feeds that we saw. So I know that it was 18,000 RPM at. Sorry about that. So for our speeds and feeds, sorry, I had to go change something. There was nothing. I just go check that I was not insane. Select that. That's the right tool, as I mentioned before. I know that this is, looking at my speeds and feeds document, I know that this is 18,000 RPM at 180 inches per minute. Everything else will adjust accordingly. Those are really the 2 main ones that you have to enter. Next, we can go to geometry. So this is actually when we select the parts of the cut that we want to be cut. So I know that it is just going to be the circles. We can do this pretty easily. Select that and that. This little yellow line is the path that the drill bit is going to take, the drill bit or mill. Select all of them. You can see it. There's like ways to automate it using these down here, but for the most part, I'm just going to like auto select them. Now, heights are basically just involve at what point you want it's heights. When your CNC is moving, how high do you want above the stock do you want to go? When it is retracting after doing a cut, how high does it want to go? That is all dealt with in here, but it is not essential for the cut that we're going to do. Passes, we do not have to do a lot for the bore option, so we're going to keep that as it is. Now I know everything's correct. I can just go. Great. That's our first function done. You can see the effect that it has on the stock. Like, it will automatically like cut it out, you'll see. And we can even simulate what that would look like if we go right click and go to simulate. Here we can drag through and go through the actual path that it takes. Next, we're going to be doing the contour. Now that we have our hole done here, we can drill the holes in to secure it, and now we're going to go around it with contour. Just as we have before, we have our 4mm 2 flute OAL, 50 OAL. I can just click on the bottom. The top. Do not click on the top. If you click on the top, it will cut down to the top, which means that it will not cut at all. So you have to click on the bottom. Next, we go to tool. I should have done tool first, but it doesn't matter the exact order that you do it in. It remembers the choices that I made last time for 18,000 RPM at 180 inches per minute. I mean, that's about all I need. I don't need to change anything else. However, I do actually want to go to passes. This is a very important thing. It's called multiple depths. So if you think of our drill bit, it cannot do the entirety of, actually maybe it could do this, but it is best and easiest on the drill bit for it not to cut the entire depth of the wood at once. So we can do multiple depths where it will do like steps downward as it's cutting. So I can go back to my CNC speeds and feeds page. Our depth per pass is 0.065, which I can just type right in, 0.065. And I mean, not a lot else to change here. We just know what the tool, we know what the tool is, we have the right tool, we have our right speeds, and we're good. Look at that. You can see the different steps. You see the little blue lines are the steps that it would take. And if I select both of these, I can right click and go to simulate. And then I can see the entire thing from start to finish of right around after it finishes these holes, like right there. Then I would drill the material down to the bottom and then it would cut around. You can see how that would look like. Great, so I'm pretty confident with that piece, but that is just wood. It gets increasingly more difficult when you do anything with aluminum. If you don't know, because aluminum is extremely soft, it is also easy to work with, but extremely soft, and that also means it has a low melting temperature. So if you have something moving incredibly fast, causing a lot of friction, it will create a lot of heat, and it will effectively weld the little shards that come off of the aluminum to the bit, which is a lot of strain on the bit and breaks the bit many times. There's many other precautions that you have to take to prevent this from happening, especially when you're actually on the CNC. And that mainly regards to where you zero. You don't want to zero too low down, or you don't want to zero too high. And you'll see what that looks like. But you also are going to have the sprayer on. There is like a way to do like a sprayer in Fusion 360 that we don't really do. I'm just going to be doing the exact same thing as I did last time, where you go to setup. It will automatically select that because it assumes I'm going to continue working with that, but I'm going to say, no, I'm going to be working with this. And then go to stock, and then relative size box. That it will default to relative size box when you're clicking on something new for a whole project, but if you're doing something specific to like going from this model to this model, you're going to have to reset it to relative size box. I know that I want 0 top offset, because I know that where I want to zero it, I do not want to be any higher than where I want it actually to be zeroed. Great. I'm going to put my 0 point up here. We're looking good. Okay. So from here, we're going to do the same thing that we did last time with a bore. I'm going to start off by selecting my different holes. And I know, just off the top of my head, I know that I have to go at 12,000 RPM. Yeah. 12,000 RPM at 72 inches per minute. So it is much slower on aluminum because it is harder. Like, you don't want to speed up on something that's harder. Sounds kind of counterintuitive, but it's just how it is. I think if the harder you press down on like a knife, the more it's going to hurt your hand, even though it may cut something, you know? That was probably not a great analogy. Just go with it. Passes. We're not going to change this at all. And that's our bore done. Now we're going to go to contour again. Select the bottom face as always. If you don't know, this little arrow in here dictates if we're going to be cutting on the inside or outside of a contour. We're going to be cutting on the outside. I've had to adjust that a few times, and it's happened in the past. We're going to go to this. It automatically knows our speeds and feeds because I just entered it the last time. But in regards to passes, multiple depths are imperative. On the document, it says 0. It says varies per part. I'm going to tell you that most of the time I've had the most success with 0.03. It is going to be very small, but it's going to be successful. And that's really all we can ask for. In case I haven't explained this, the step downs are just how big the jumps are from height to height. So the distance from here to here, that is the step down. I mean, this looks like a pretty solid part so far. So aluminum, we will get into a lot more later. Now we're going to go to our last little part here. We're going to be dealing with adaptive clearing, where in order to utilize it, the best way to do it is to select the very bottom. You'll see it has pocket. Like I can even do like contour, and that'll also, or chain, I guess you call them, but whatever. Select the very bottom. I'm going to go to tool. I know that I'm going to be going back to the wood speeds and feeds. So that's 18,000 should be at 180 inches per minute. This actually no, I don't deal with tabs yet, but this part is quite simple. There's not a lot of change with this. Oh wait, no, I did not create a new setup. So it will do that if you do not create a new setup, and it will be unusable. But I'm just going to speed through this. Our top offset is 0.0 with our 0 point set at the top corner. Now we do adaptive clearing. Guess you'll be able to see it again. Select the bottom at 1800, at 18,000, at 180, and we're going to be keeping our bit. But for these thicker pieces like we would have here, typically we would use a longer bit. Luckily my bit is just long enough, but the 0.4, sorry, the 4mm bit is just long enough. I would typically use a 75mm bit, and if you just think of leverage, if there's a longer shaft, it's going to mean that you cannot press as hard on it without it breaking. So that would mean that I would just go a lower depth of cut, or I don't want that on, but that may just turn on at random times. I'd want a lower maximum roughing step down, but because it's the normal bit, I'm just going to go 0.65. See, if you don't know, because it is a circular bit, you will not be able to get perfect corners like this if they're not on the outside. I would typically just like take a file to this, or I'd cut it out with a knife. Doesn't really matter, but you can see the multiple layers, and I'm just going to, sorry, ran out of this disk space. Basically, all I was going to show you was that the corners were too tight, as you can see down here. It is too tight for a round drill bit to get the exact corner. So likely I will just go down and file or sand that down, or cut it with like a knife or something to get that little corner. But that's what it looks like under the simulation. And we're going to go to contour, and this is once more just a little wood piece. So select the bottom contour, and our speeds and feeds are right. But something that I will talk about is going to be tabs. Tabs are, you can see them here, little like rectangular things to hold in the because this piece is not going to have any screws in it. We have to have some other way to keep the piece not being flung off, and this is going to be the tabs. Because the greater piece of stock is going to be secured down to the board, as long as these tabs are here that secure this piece to the stock, we should be fine. You'll see what that looks like later. You can change some of the parameters, such as like what they're shaped like, but the defaults are fine for what we're going to be doing. Oh, I meant to change the depth of cut. Depth of cut, 6.5. And I think that's good. So that is the main functions that we kind of need to do. Besides that, all I can really show you is, what was I going to show you? I was going to show you some little nuances, like, no, oh, in case you want to like select what it looks like, you can click that over there, but I'm going to just show you how to export these pieces. So I'm just going to be doing, because these two parts would be done together, I will select these a little bit later, but for right now we're going to be doing two individual parts, because part one has to be drilling the holes through them so that we can secure the screws with a pause in the middle. If we don't have the pause, then it will go straight to cutting the outside, and that was all for naught. So I'm just going to right click, and we can click on post process, and that'll bring this up. So right now I'm just going to be, I will have the post in the description as well, but basically all you do is click on folder, and you select the, I guess, like G-code compiler. I don't really know the term for it, but that's all there really is to it. I almost always name my cuts. It would be the like material it's made out of, so this would be wood, and then I just go straight to black, and I do 1 for part 1 of 2. This, in all of its glory, is the CNC machine. Up here, you'll see this is going to be our central command area, but for now, we're just going to be taking the USB drive. And I'm going to select the output folder in which we would put it on the USB drive. This is a USB drive that I have at my house, and it's not the actual one that I use for the CNC. I'm just going to select it anyway, and comment. You don't have to do any of that. Just click on post, and as you can see, I can click on this. It's in here, but there's a lot of other stuff in there. Yeah, we can do this for the big part as well. I'm just going to select both of these, just like we did for simulate. go to post process, wood, stand, 1. And it's just going to be 1. That's all there is to it. Post. Oh, I immediately forgot to do the second part of this. So wood, plaque, 1. Or 2, because this is the second part of it. And then aluminum follows a similar pattern. It's post process, al for aluminum, plaque, 1, post process, al, plaque, 2. Great. Everything else will be done later, and you'll see all of that in person. Alright, so significant time has passed since our last part of this video, but I will now be changing the bit. As you can see, of course I've changed the bit a lot in between those 2 points, but I feel like right now it's good to redo this. So I do have like very oversized wrench here, but it just makes the leverage easier. So you just grab it like that, twist, it'll pop, and you can just unspin. Once it's out, you can just pull it out if the bit is long enough. I do not recommend pulling it out that way, but I guess I did that. Otherwise, you would have it like this, shove it out, and then do not grab like this length of cut part. That will hurt. Grab the part that's not. I'm going to be changing this out for a shorter bit. Alright, so this is 50 OAL versus 75 OAL, or overall length. You can see that difference. Just going to slide that in there. Tap it down until you can see like that little marking. I don't know if you can see that well in that light, but there's a change in where the like special treated comes in. Here, let's see if I can get that in better light. See, like right around there. That's where you want to push it to, unless you need to have just like that little bit of length, in which going a little bit longer will not hurt. And now you just slide that on. Start twisting, put this back on, this back on. Now make sure to make it tight, but not too tight that you won't be able to get it off again. If you make it too loose, then it will come off when you are running the machine, which is really not good. Alright, so I am also redoing this part, so apologies. This is a 1/4 inch ply. I would have liked to have better wood, but this will do for now. All I'm going to be doing is grabbing a screwdriver, and with wood, you can just go right through. Now, I know I'm not going to be using this whole board, so you'll see me just use, like, portions. I'm just going to be using this little section here, because right here, there's the blemishes. Over here, it's fairly clean. I didn't do it, like, too specific, just like a general square. I know that my part will only be about that big, so it didn't really matter how big as long as this was bigger, that's fine. If you are doing a bigger piece, you'd want to go to the very edge of the board, which is, yeah, you just go to the edge of the board, and with that, that means that this center part might warp upwards. If you're going to do that, you want to make sure that if you put a screw in the center to make sure that it does not puff up, you have to make sure that your cut will not go through the screw, which I'll explain a little bit more later in the PowerPoint section. Now, I'm going to be repeating this step quite a few times. We're just going to be zeroing the machine. So that's the bit right there. If we go up here, the arrow keys are a little bit off, where down moves it this way, left moves it to the right, and right moves it to left, and up moves it backwards that way. So using those directions, just going to bring it over. Going to get like generally in the corner, shift it. This button shifts it down, this button shifts it up. You can see go down, that's a little bit tight, down, down. And you can see we're like nearly touching. So if we want to go in smaller steps, we enter what is called the step mode. So right now you can see right there, cont for continuous. If we press the mode button here, that will shift to step. If we can see how big the steps are that it goes down, which is 0.01 millimeters. That's really small, and we're going to be here for a while if we just continue to press it down, which we can if you want to, if we want to do really precise measurements. But you can see if it's still spinning freely like it is, that means it's not touching the wood. So to shift that, if we press this button here, you can see the bolded goes down to SJR. I don't really know what that stands for. Make that 0.1, and then you'll see actual changes to how much it spins. I'm just going to press the down button just like you did before. Down, you can see that little shift. Still spinning freely. Down, down. Still spinning freely. Down. And I think that'll be it. No, one more. Yeah, there we go. That's just about zeroed. Now, to actually zero the machine, so it knows where its zero is, where to go from, press the all zero button right here. That's what I did. Sorry, that was off screen. So, now that that's done, to actually start the cut, actually, now that I'm realizing, you can see that this bit is right in the line of this screw. So what we could do is we could either go re-zero it and make the 0 to this way, or we can move the screw. I'm going to be doing the earlier, which is to shift it. Just like before, gonna go mode. Also, there's one more like in between step. I don't really know what MPG is. I believe it's for the 4th axis, but we don't need it. We can just go to continuous. If we go up, back, and then I can just go based off of this, where, see, the Z is how far up and down we are. So I can just press this until switch back to step. And then once this reaches 0, I know that I'm at the same exact Z level that I was at before. So now it is no longer in line, and now it is just barely touching and slowed down by it. You can see that like a little like circle there forming when you know that you're at the right 0. Great. Now we all 0, press page. I'm going to close these doors. Page will bring up a list of just like the cuts that you have. I just have wood plaque and wood plaque 2 on it right now. I name like 1 for the very first cut and 2 for the very second cut. Yeah, go press these keys to go down to wood plaque 1. If we start, you can see it cutting. All right, I'll see you later. All right, great. So the reason that I did this like wood plaque in 2 separate parts is that if we go around the little holes that we have right now, the part would chip out like as it was cutting, which is not good because there's nothing holding it to the base plate. So what we're going to do is, using the holes that we just drilled, we're going to drill more screws in it so that when we go around, it will stay right where it is. Pop this open, and just using the same exact buttons from before, I can safely go to continuous, move it out of our way. Make sure not to de-zero it, because then that'll mean that we basically have to restart. Alright, just blow that off. See, nicely drilled holes. This may be going a little bit overkill, but drilled holes for a reason. Great. Now, we can start the next part. Close this up. So to bring it back to its 0, you press second 0, 0. Sorry, X minus, but that's just what I say to myself. Now shift over, just like we did before. Page, down. We're going to be going to wood plaque 2 for the second cut. Start. With time, you'll come to hear what like a good cut sounds like. This is fine. Wood is quite hard to break a bit on, and it's not exactly screeching in everybody's ears. So I'll see you in a minute. All right, now our cut is finished. Just as we've done the previous 2 times, shift this over and remove the screws. Sorry. Oh, so what we happen to have is we did not go deep enough with our cut, which means that you can see we're not seeing the base plate there. We are just seeing the wood continued. So what we can do about this is we can either redo that cut and go lower, or, because this part is wood, I'm just going to take a little saw, go through it. Alright, so this is our part. It is, yeah, pretty basic. I'm going to sand that off. I would normally not like cut it out like I did if it was a metal piece, but because this is just a wood piece for a tutorial, it's nothing big. Alright, so getting started with our aluminum piece, I already started with a board that had holes drilled in it, but you will need 2 drills here, one for drilling the holes in the aluminum and the other for screwing in the screws. I also will show you a quick thing on Fusion 360. This is, as I mentioned, warping beforehand. There is a workaround that I've found to be incredibly useful. I'm just going to be going to the aluminum, the bore in the aluminum. There is a section where it is called heights. If you go to heights, there is a bottom height, and you see I made the offset 0.35. You'll see why I did that later, but the basic idea is that with the warping board, a consistent way to always cut the same amount of aluminum and not to break a bit is to set where your bit's 0 is a little bit higher than where the actual corner is. This means that even if a part is warped upwards, it means that you will not be cutting anything, and when you actually do cut that part that is warped upwards, you will only cut a small amount, not enough to break the bit, which definitely helps, and is how I've gotten through this robotics season. And now, we're just going to continue drilling in the holes to our aluminum. Okay, well, whatever. Alright. Now that we have that, now I'm going to just show you exactly how I zero it. Of course, this is not too big of a piece, so the likelihood of it being warped is a lot less, but I will show you. I'm just going to set my like dummy 0 point of like where it would be right about here. All right, so set that just about where I want, 0 that. But what I will do is I will continue to drag the bit along this way. You can see there's like a little bit of space. We have to see if that space increases or decreases. Now, luckily it didn't. I'll shift over here, right to the center where it is most prominent. Right there, got a little bit close, but none of it is any worse than the position we originally had. So I'm gonna reset, go back to our 0. I'm going to say right around. I'm gonna swap between mode, step, and go down, right there, up there. One more up. Great. Now, gonna go put the files on the flash drive and we'll get back. Alright, so I'm gonna re-explain this. So a major part with cutting aluminum is keeping the bit cool. If the bit heats up to the melting point or like making the aluminum malleable when it is cutting, what will happen is it will end up sticking, the aluminum will end up sticking to the bit. I will show what that looks like right now, and I have a little video of me attempting this earlier and messing it up. Yeah, so that's not good, and as you can see, the sprayer is already kind of leaking. We use a sprayer from this alcohol up here, drips down into the sprayer here. Thank you to Neil for designing this. This right here adjusts how much is coming out or in. The tighter you go this way, the less that will drip out. And as you can see, it's already stopped. I'm going to leave it like this for right now as we're setting this up. To turn on the sprayer, to turn on the actual air that is coming out, come over here, this little thing here. Why is it not plugged in? Great, plug it in. Great, plugged in. Turn that on. You can feel the air coming out. Eventually you'll see like this area of like dryness. And right now I think we're ready to start our cut. So I'm going to, because the holes do not generate a whole lot of heat, I'm going to turn this up just so that I can start seeing those little droplets forming. There. You can see that this little part here, if you turn that all the way in, that kind of locks its position. So now we're ready to start. Close this up. Page. I'm going to be going down. Where is my files? Hold on. This just happens sometimes, and I don't know why. There's no real way around it. This is like quite old. All right, there. See, Alplac 1, Alplac 2. I'm going to select Alplac 1. I'm not going to hit start yet. Now I'm going to turn back on sprayer. Great. And start. See you in a bit. All right, so that went great. So the first thing you want to do, I already turned it off, is the sprayer, and then to prevent it from leaking anymore, slide this right up here. And in case I haven't already said this, if a lot of alcohol gets on the board, then that will lead to warping, which will only break bits. Just like we did before, shift this out of the way, and we can once again start drilling our holes. I'll skip over that. Great. Now, as we did before, second 0, 0. Going to be going over. All right, slide our sprayer back on. So contours going like around the bit, going around the actual part, that will generate a lot of heat because it's traveling very fast. So I'll turn the sprayer on fairly high and turn the air on to see what that looks like. A lot of knowing when the bit is going to break is actually sound. So a lot of these things are kind of hard to describe and are mostly experience. There, now it's coming through. I'm going to turn that. Actually, I think that's good. Yeah, let's just send that. Close that up. Page, Alplac. That sounds pretty good. Just like one constant sound is always good. Look at that. Great. Alright, so our piece is finished, and I've already removed the sprayer. Shift this out of the way, and we'll see how good this looks. Looks pretty good from now. Alright, so our piece came out. I mean, I don't really have any complaints with it. Maybe this little chip here, which knock off with my finger. Yeah, looked great. For first aluminum piece, I'd say that this is fairly simple. I've done most of the pieces that I've cut for the robotic season go throughout this entire size of the table. So yeah, it will get progressively more difficult. But for now, I'd say that's a pretty good starting project. But yeah. So this is what the two parts put together look like. Yeah, that's kind of a testament to the accuracy, is that the parts slid right in. Yeah, no real hassle. Alright, so for our final piece, I was going to go ahead and zero it, and then I realized I should probably address this. If you have a piece of stock that is too big, your drill bit, the bit on the machine will not be able to reach the bottom of the stock without this like upper gantry hitting it. Luckily, this one is just barely above it. But for a future, you can either use longer bits, which is going to require a smaller depth of cut, or you can just, as I will do, basically bring it up, push it out a little bit, and put it back in. So I got the gantry out. What I'm going to do is put that in there, shove it out a little bit. Maybe I need something a little bit tighter. Here, got the gantry, shove that. It should come out a little bit, and that should be more than enough. You can see, and put that up against there. That is able to touch with plenty of room at the very bottom of the stock. So we can just use this bit. Alright, so I have now loaded up the flash drive, and I have zeroed at the very top of our stock, but there's literally just about nothing else to change between this and the little wooden part that we had before. Running this should give us everything that we want. Like, there's not a giant difference between using thin and thick stock besides using a different sized bit. If you have a longer bit, then all that really means is that because there's going to be more leverage on the bit constantly pushing on it, you're going to want to have a lower depth of cut. Just keep that in mind. Like, I've done very deep cuts where I've had to do like 7 or 8 different rotations of the stock. That is when you should have a longer bit, but it can also be detrimental because I've also broken many bits this way. Now let's just start. You can see for this cut I'm going to be using tabs, which is instead of having the screws going through it, there's going to be little parts that are left of stock in between the material and the part that you're producing. So we got the wood stand is what I called it. Enter and start. And it will bore down. Great. Alright, now we have our part made. I do need 2 of them, so I'm going to do the same thing, but shift it over. This is as simple as just moving the bit to here and zeroing it once more. This is really the process that you're going to have to get down for CNC machining, is just prepare your stock, screw down, make your zero, start the cut, make sure everything is processed, either washed off, sanded, filed, or if you really want to get good at it, you can chamfer the edges using a special chamfer bit for this. But I'm not going to get into that for now. I'm simply just going to make another piece. Alright, got our pieces. I'm just going to undrill it. Actually, you know what? Let me move this first. Great. Alright, so I forgot to record removing the tabs, but the idea was just like you clip them off and you sand them down. There's not too much to that, but I would just like to say that this is the final project that I'll be doing for today. All this, of course, it's not perfect. First off, these parts I should have mirrored because they're going to be on opposite sides. And yeah, it doesn't really work that way. But, see, it would look like that. Yeah, I think this was a great project to kind of demonstrate the different types of machining you'd likely be doing on the CNC. There will be bigger projects that will require more time and warping will become more prevalent. But yeah, I'm happy to leave you guys off here and try it yourself. One last thing. I would also like to make this out of acrylic, and acrylic I will also do. Down to Alplac 2. That is no. I'm just going to be kind of going over the problems that I've faced in my times of CNC machining and trying to prevent them from happening to you. So first off, the problems with the CNC can be really dangerous. If you don't know that 70% alcohol can still catch fire, so don't have flames around the CNC. If you break bits, which are hot and sharp, and get flung when broken, watch yourself. Be prepared to turn off the machine quickly. So that means that if something goes wrong with the machine, it's making a noise that you don't like or it's not good, just turn the emergency stop. It's the big red button that you twist. Just hit. And watch the machine. So don't leave the machine. I still don't. You have to be really confident. And like, it could be like some hard part in the piece of wood that you cannot see at that point. That is what breaks the bit. You don't want if you leave it alone, then it can cause much more damage than if you're there. It is hard to break a bit on wood, but it is possible. So for wood, it's kind of looser, so I would just recommend following the speeds and feeds because the speeds and feeds that I have are almost universally applicable for wood. But just like aluminum, it is perfectly fine to turn down the depth of cut without any danger. So for longer bits versus having a shorter bit, it is best to, if you can, it is best to have a short bit. If you're going to have a longer bit, then that means that there's a lot more leverage on the tip of the bit, because there's, it's leverage. You have more, if you have a bigger lever, the easier it is to pull down, more energy you'll get out of it. For short bits, it's much harder to break. For longer bits, you only use it if you have to reach somewhere that you can't really reach. So get to know your diameters, and that also includes the metric system. The main drill bit size that I use is 4 millimeters. It's kind of like a hit-all, jack-of-all-trades size. I had relatively no actual use to change the bit. If you're going to be doing something with very small details, it's likely something that you can't really do on the CNC to begin with. And if you turn down that diameter even further, then that just increases the chance of breaking a bit. And get to know your thickness. This one's just very simple, where if you have just 1/4 inch versus 1/2 inch is really the main thing. If you are putting in that your piece is 1/2 inch when it's really 1/4 of an inch into like Fusion 360, it will drill 1/4 inch into the plywood, which isn't good. Like, I know this sounds very obvious, but it really affects you more than you think. Just like aluminum, the bit is very hot when it comes off the mill. Don't touch it immediately. It's a lot of friction going through it. It generates a lot of heat. I've burnt myself pretty bad, and I've cut myself pretty bad as well. The bit has to be sharp enough to cut through aluminum, so be prepared to avoid touching the actual blade part. It is very easy to break a bit on aluminum, though. Aluminum is soft and it melts at a low temperature. So although we do have special cooling bits, which is titanium carbide and an alcohol spray to keep the bit cool, it can still get broken, the bit broken. Too big of a depth of cut, moving too fast, the sprayer getting knocked out of place or not squirting enough will cause the bit to break. But you can't really flood the piece either with alcohol, because not only will you have to buy alcohol more often, even if it's not on your dime, it's still kind of expensive. And flooding the corkboard too much will warp the corkboard permanently. And you'll see in a bit why a warped corkboard is that bad. But just generally, I would avoid cutting aluminum until you're experienced cutting wood, plexiglass, and or acrylic. I don't recommend trying anything other than the short 4 millimeter bit. I said short, but it's 50 millimeter, it's 50 OAL. This is the bit in the tool library attached in the comments. All of the tools I believe I showed you are going to have a link to a Google Drive where it's just a quick import. So this is a little demonstration, I guess, little graphic about what happens with a non-warped board. So, can I swap this? See right here how it is appropriately leveled at the very top, where it is zeroed at the top, and it goes down an appropriate amount. This, let's just say for sake of argument, this is a good amount. It is zeroed at the correct level. Yeah, you can see what it looks like across. See how there's no change in elevation. But if we have a warped board, we zero it at what appears to be the correct level, and although it initially goes down a correct amount, over time, like towards the center of the warp, it will have a much bigger depth. That doesn't seem like a lot, but that is definitely enough to cause the bit to break. I believe I included a video within this video about how it looks when it is warped, where it starts off with a very normal sound, then over time it just kind of shifts to darker, I'm not describing sounds, but darker, deeper sound that means that the bit is going to break. So the best way to secure the warped boards or sheets is just to screw down the sheets in more places with screws, or to use a smaller board. If a first layer cut is successful in a warped board, then the following will be successful too. So this is kind of a weird concept, but if this bit goes across, let's just say, for sake of argument, this bit goes across this entire part flat. That means that there will be no more warps in the areas that it's going to be cutting down. So, although this is up high right now, it will always be leveled to this line. And a real warped board situation would not look this obvious. This is just for demonstration. And I think I have an animation? Yeah. You can see how over time it shifts the amount that it is cutting. But some other problems I've run into. Hitting screws will always break a bit. Just don't put a screw in the path of the bit. And that seems kind of silly, but If you're really worried about it, then I would recommend just putting your 0 point really high at first, having it go around and making sure that it doesn't hit a screw. It seems silly, you don't always have to do it, but especially if you're working with very small stock, if you have like an expensive piece of wood that you only have a little bit of, it's all good. The stock is the same size in the CNC and in Fusion, but it is not going through. Try setting your 0 a little bit lower than before and retry the cut. This could just be like small measurement errors. It's fine, but like for wood, it may just like chip out. For aluminum, you may just have to go lower. It's nothing big. Like I said before, it won't have like a giant problem with cutting unless it's warped. The aluminum is welding. There are plenty of causes for this, but immediately try turning down the depth of cut, movement speed, or unscrew the valve for the sprayer slightly. Make sure to aim the sprayer at the very tip of the bit. If you aim it very high, the heat will not transfer as well. The main thing with the alcohol sprayer is not just spraying on the tip, it's also spraying on the part that it's cutting. So spraying it directly on the tip is by far the best option. The CNC is cutting way too high or off the stock, even though I zeroed it correctly. That means your axis origin needs to be on top of the corner of the material. So this is how the axis origin looks like in Fusion. If it is going way too high, one of the possibilities is that you've placed the axis origin on the bottom corner. I did this a lot when I was first starting off, and this is the goal. You want to have it at the top corner rather than the bottom corner. If you start at the bottom, CNC will think, oh, I start here, I have to go up to cut out. But no. Some more random problems. If you're cutting out an object with holes on the inside and a contour on the outside, make sure to cut the holes first. If not, the object will not be secured and flicked out mid-cut by the bit, which is not good. So you can see what this would look like if I just have this board and I have these holes in it. If I cut the contour first, that means that there will be nothing securing this board to the cork board. That means that it will ship out mid-cut, and that means it's not good. It could either like jam into the bit. I've broken, I think, 3 bits this way. And this could happen with wood as well, so it's not just restricted to aluminum. The basic idea is just make sure that you have screws in your stuff before you do anything. In Fusion, using different bits in one post-process will give an error, but it will not tell you what's wrong. This is kind of like stupid, but it's annoying. If you have a setup and I want to do both a chamfer and a like contour, like if I'm going around this with a like this, then it will, and it's in the same setup that I export, it will not tell you what's wrong, but it will not export anything. So just make sure that they're in different setups or you're exporting them as different toolpaths and you'll be fine. If you're trying to do a chamfer on the top, which I would recommend you try to do, it looks very nice, try to put the 0 a little bit high. If it's too low, it gives the object another really ugly lip, and you can always try the chamfer again if it's too high. So this is simple demonstration, but if this is the stock, this is what the chamfer bit would look like, where it has that like 45-degree angle. But if you set it too low, then this little part here will cut into here. And it does not seem bad, but it looks really, really bad. So just simple piece of advice, just put the 0 a little bit higher. Of course, you'll find problems on your own. My default for finding out what's causing a problem on the CNC is to turn down the depth of cut. When I refer to depth of cut, I actually am referring to the maximum roughing step down, but the depth of cut is just the simple name. Generally, it's kind of hard to do research, but if you have like a problem with Fusion in particular versus the CNC, you will find it pretty easy to find answers. If you're looking for answers on the CNC, like the Amio itself, it's much more hard to find answers, but you can always talk to one of the higher-ups, or you can talk to head of manufacturing or me or whoever. And just generally, don't cut corners. Seems very simple, but this is by far made me break the most bits possible. This could either be in pursuit of finding a way to make it faster, or in just like a way of just simply cutting corners. It will either give you bad pieces that you can't really use, pieces that will break your bit, pieces that are sharp and cut me, like I've done before, and can even like break the motor of itself in the CNC. But that's all.